Yeah, the next topic we have to take up now is inheritance. In this, we have to learn protected keyword, constructors in inheritance, typecasting. We have seen typecasting in value types earlier. Now we have to work with casting in reference type, static and dynamic binding and virtual methods, abstract class and object. This is basically the agenda for the whole topic. Now, when do we apply inheritance in applications? When do we apply inheritance in two different classes? Now take few examples as I have given there. Car is a vehicle. Car is a class, vehicle is a class, and the relationship between them is car is a vehicle, we can say. Like that we can say faculty is a person. Student is a person. Mango is a fruit. Chair is a furniture. Scientific calculator is a calculator. Computer is an electronic device. Like that I can take so many other examples. You take any two entities and try to see if you can put is a relationship between these two entities. And if you can put is a relationship, there is a provision or there is a possibility of inheritance relationship between them. Otherwise we can say there is no possibility. For example, chair is a table. No, it doesn't suit. And try to read the other way. Table is a chair. That also doesn't make sense. So there is no inheritance relationship between chair and table. Take vehicle is a car. Not necessary every vehicle is a car. So that is wrong. But car is a vehicle is a valid sentence. So looking at this, we can say that vehicle is parent, car is a child class. In inheritance, we always have a parent and child relationship. Let me also clarify, many people would say that father and son is also an inheritance relationship. They are absolutely wrong. For example, pretty straightforward, just read, son is a father. No, not necessary. Father is a son. Yes, but probably not between son and father. He is a son of another father. But then yes, this doesn't make sense. If father and son is inheritance, we should say father and daughter should also be an inheritance relationship. For example, daughter is a father, son is a mother. Do they sound logical? Absolutely not. That's how I say parent child does not mean father son or father daughter or mother son mother daughter. Parent child basically means here a parent class and a child class. The relationship between the parent class and the child class is a child class is always going to inherit all the properties from its parent class. Everything what is there in parent will be inherited by a child. Everything what is there in parent we can say is also there in a child. All the features, all the behavior, all the functionality, all the state, every aspect of parent is inherited by a child class. So this is the basic point about inheritance. Find is a relationship between two entities, and if you can find is a relationship, you can say there is a inheritance relationship. If there is no is a relationship, there is no is, most of the time there is no inheritance applicable between those two entities. So now when we talk about parent, child, parent, all this story, majorly we have to spend rest of our time understanding inheritance implementation in object orientation. So I create now a new project. Let us say we develop now a console based application and we give here something like inheritance demo. We have static main. As usual, I don't need all these things. I'm deleting it. I can delete this, and to get everything aligned, Control K D, properly indented. Now I want to create a class. Let us say we have a class called as parent. We can begin with C parent if we want, class parent, more readability. And we can say that we have class C child. And we want to say that class C child inherits from parent, colon C parent. This is how we apply inheritance syntax. Now what is the benefit of inheritance? Why should we go for inheritance? I would see inheritance from two angles. One is generalization and the other is extendability. If there is something which is already existing, we might want to extend that. For example, we might have a calculator. The calculator I may want to extend with, basic calculator we would have is all add, subtract, multiply, divide, memory plus, memory minus, square root. All these things you will find in basic calculator. But when I want to extend this and want to have some extra functionality like sine, cos, tan, or logarithms, hexadecimal form, binary form, basically all scientific operations, I want to extend over and above what we already have in basic calculator. So in such kind of requirements, instead of adding these extra new features in the existing calculator itself, I would prefer writing one basic calculator and then further extending that basic calculator with the extra functionality that is scientific calculator. Thus, I would say a scientific calculator class is inherited from the basic calculator. Scientific calculator is an extended version of the basic calculator. This is the example of extendability. We are extending something which is already existing and adding some extra new features into it. The other reason why we go for inheritance is generalization. For example, I might have a let us say person, which is a general form of both faculty and student. Student is a person, faculty is a person. So as a faculty or as a student, whatever things you would have common, rather than writing those things in the individual class, we would prefer putting them in a common person class. So generalization. Similarly, we can say vehicle, car, scooter. Vehicle is a generalized form of car and scooter, and thus car can inherit from vehicle, scooter can inherit from vehicle. So whenever we talk of inheritance, it is purely based on generalization or extendability. These are the two major reasons why we would go for inheritance in object orientation, and both of them give us the same advantage again ultimately, that is reusability factor. Something which is already existing, we are trying to reuse it, or something which is not existing and we want it to be common between many entities, we again put it in the common parent class. So the base of inheritance is on a relationship, extendability, and the generalization factor. So keeping these points in mind, one would go for inheritance or one would not go for inheritance. Let us continue with the syntax now. So here I am saying we have a class called as cchild, which is inherited from cparent, implies every member of cparent is inherited by cchild. Now what is that a parent class can have? I can have here one public member. Let us call it as public A. I can have one private member. Let us call it as private A. And I can have one protected member, integer protected A. We already know what is public and what is private, but to repeat, a member which is declared as public, a member which has the access specifier as public, is accessible everywhere within the class as well as outside the class. Whereas a member which is declared as private is completely local to that class. It is not accessible outside the class. And third is protected. A member which is declared as protected is in between public and private, implies it is accessible within the class and is also accessible to methods or members in child class. Child class has access to protected member. But a class which is not a child of cparent cannot access a protected member of the parent class, cparent class. So only child classes would have access to the protected member of the parent class. Otherwise, protected member is like private, not accessible in non-derived classes or non-child classes. See, I am using the terminology parent-child. Instead, you can always use the terminology of base and sub. Base class, cparent, subclass, cchild. Let us try to understand this protected again. I have now another member added here, public integer PUBB. Imagine we have 3. Now I'll put here public void some method foo. Now I want to access the members of the parent class here in child class. So what all members of the parent class I can say? This dot PUBA is equal to, I can set a value, this dot PRIA not accessible for the simple reason that it's a private member. Private member of parent is not accessible in the child, so ignore it. I'll say protected A is equal to 1. As I said, a protected member of the parent class is accessible in child class. And then we have got, of course, the current class member, this dot PUBB is equal to 1. So these are the three members of parent class and including child class which I can access in the child class method. Now I create here a variable of type cchild. Let's say C is equal to new cchild. Now I say C dot PUBA is equal to 1, C dot PUBB is equal to 1. Public members of both parent and child are accessible. C dot protected A is equal to 1. The protected member of the parent class is accessible in child class using a reference variable of type child. So far, no issues. Now see this special case. I create a variable of type parent. Using this P, I am trying to access public member of the parent class. I can do that. Using P, pretty obvious, I cannot access public member of a child class because variable is of type parent. A variable of type parent cannot access child class member. It's a common sense. Ignore it. Now, important point is using variable of type parent, we are not able to access a protected member of the parent class in child class. See, what is the rule I said? The protected member of the parent class is accessible in child class. But the rule is it should be via a reference of type child. Like this is reference to an object of class child. Here C is also a reference to an object of class child. But if you look at parent, P is a reference variable of type parent. Using a reference variable of type parent, a protected member of the parent class we cannot access in child class. Very, very, very important. Very important interview question this can be. I repeat, the point is a protected member of a parent class is accessible in child class as long as the child class is accessing that variable using a reference of type child. In other words, a child class method cannot access protected member of the parent class using a reference variable of type parent. Generally people ignore this point, but I hope you would have got clear understanding of what exactly is the meaning of this term. So we have now got parent class, we have got child class, and now we have clear understanding of the keyword protected. What is the scope of a protected member of a class? A member which is accessible within the class, a member which is also accessible to the derived classes, subclasses, as long as the subclass is trying to access using a variable of type child, subclass variable, not a parent class variable. That's all about keyword protected. Now let's move further from here. Now in main, I'm trying to create an object of class child. Say C is equal to new child. How many members do you think are allocated memory? Is it 3 or is it 4 or is it only 1? If you give the answer as either 1 or even 3, you are wrong. 1 is wrong for the reason that we are not creating object of class only child. Rather, child is completely dependent on the parent. So whenever a child class object is created, all the members of the child class are allocated memory. The member variables which are there in child class and also member variables which are there in base class. Now why somebody would say answer as 3? The reason could be, you might be thinking that how can a private member of parent class get instantiated when the object is of child class? That's an absolutely wrong thinking, wrong line of thinking. Say for example, now if I create an object of parent class, do you think only one member is allocated memory because the other one is private and protected, which are not accessible? Keep in mind, able to access, not able to access is a different issue, and allocation of memory when the object is created is a different issue. So the point is, whenever a child class object is created, all the members of the child class, which includes all the members of the parent class, irrespective of their access specifier, are allocated memory. That means when I create an object of child class, 4 integer field members are allocated memory. That is public A, private A, protected A, and public B. All these 4 members are allocated memory. None of them is skipped. So that's what is the meaning of child class object created. Now the point is, we have to discuss how is the code going to execute. Let us say I have a constructor in parent class. What can be the possible constructors in parent class? Let me add all the possible parent class constructor. Can I say this is default constructor? And then I would also add here a parameterized constructor. Here I'll say this dot PRIA is equal to PRIA. This dot PROA is equal to PROA. This dot PUBA is equal to PUBA. Let us skip copy constructor. We don't need that for now. But otherwise, if you want, you can also add copy constructor. So I have 2 forms of constructor added here. The default constructor of parent class and the parameterized constructor of parent class. Now I may want to add these 2 forms also in the child class. So I'll simply put here C child, public C child. Now the point is, how many parameters would I give for the child class constructor? Yeah, if you have given the answer as 3, you are again wrong. I already said when the object of the child class is created, 4 field members are allocated memory. So pretty obvious, I would like to initialize all the 4 field members rather than initializing only 1 or 3 field members. So yes, I would like to have here integer, rather I can say all these things what are there in parent. In addition to that, one extra member of the child is what I would like to have for a child class constructor. This dot PUBB is equal to PUBB. But then there is a problem here. PRIA is a private member of the parent class. Can I access a private member of the parent class in child class? Answer is pretty obvious. No, we cannot access a private member of parent class in child class, and it's wrong. We need to resolve this problem. For the time being, let us simply comment this. Now build our application again. Everything is, yeah, this is still wrong. I think I can get rid of this method. That topic is over. We don't need this method anymore. So I have now programmed a child class constructor, a parent class constructor, 2 constructors in parent class, 2 constructors in child class. Now let us also see in this session how to do debugging of the application. I am creating a child class object. Take the mouse cursor here and click there. This puts a breakpoint. Otherwise, you can use a short. Right, using shortcut also F9, you can toggle the breakpoint. Now run the program. say start debugging, it breaks there. After this, right click here on the toolbar, menu bar, and get a debug toolbar. This is a debug toolbar. Here we have the option step into, step over, step out. Let us start step into. We want to see from here where does the execution goes. It goes to default constructor of child class. But before it executes the child class constructor, again click on step into. It goes into default constructor of the base class. Now see, parent doesn't have any base class further, so it executes the default constructor. Then it executes the default constructor of child, and then it returns back. In simple words, whenever an object of child class is created, the order of execution of the constructor is base class constructor first and then the child class constructor. Whereas the order of visiting the constructor, the order in which the constructor is visited is child class constructor first and then the base class constructor. And obviously we need to understand the reason for it. But anyways, let us try once more. On the debug toolbar, you can say start debugging. It breaks there. Now use step into. It goes to child class constructor. Before it executes child class constructor, it goes to parent class constructor. But for parent class, we don't have any other base class. So it executes now the base class constructor. Then it goes to child class constructor, executes that and comes out. So whenever an object of child class is created, child class constructor is visited first and then parent class constructor. But it's the parent class constructor which is executed first. What is important is execution order, not visiting order. Now what is the reason for always executing a parent class constructor, base class constructor, and then a subclass constructor, that is a child class constructor? The reason is simple and very obvious. That is, whenever a child class object is created, we always would want to have a child class override something which is already done in the parent class. Suppose, for example, child class says, I want to have value for PUBA as 1. Sorry, base class says, I want to have value for PUBA as 1. And child class says, I am not happy with 1. I want value of PUBA as 2. Now when the object is of child class, what should be the value of PUBA? Should it be 1 or should it be 2? Now, if suppose child class constructor executes first and then base class constructor executes, don't you think value would override? 2 will be overwritten with 1. We don't want that. What we want is, because we are creating an object of child class constructor, whatever it does should be given precedence, or I would say should override whatever is done in the parent class constructor. And thus, whenever an object of a child class is created, it always executes the constructor of base class first and then the constructor of child class. I hope I am very clear on this. But still we have not got a reason for why is it first coming here and then jumping to the parent class. Let's see that. Now I give here, instead of default constructor, value for 1, 2, 3, 4. 4 parameters and 4 values. Now let us trace the program again. I put a breakpoint and I press F5. Again I take a toolbar, debug, step into. It executes now a parameterized constructor. You now see this is A, B, 1, 2, 3, 4. Now from here, where will it jump to? Obviously it has to execute first a base class constructor. Now most of the time people would expect it would jump here. No, it doesn't jump there. Say step into, you will see that it jumps to the default constructor. Default constructor sets the value first and then it goes down and it will initialize all the members of the child class. Simple words. Whenever a child class object is created, it's always going to go to the appropriate constructor of the child class. But before it executes the constructor of the child class, from there it will jump by default to the default constructor of the base class. After executing the default constructor, then it would go down and execute the constructor from where it has come to parent. I hope it's clear. Now, what is the advantage of doing this? Pretty obvious. Our expectation would be, rather than jumping from here to default constructor, if I can take the execution here, it would be much better. So here, like earlier, you remember we writing this, I can now place here base of what values I want to pass to the base class. Say I want to pass private A, I want to pass protected A, I want to pass public A. I would write like this. So in child class constructor, we are now calling base class constructor. Let us trace the program again. From here, step into. Before now it executes the child class constructor, it will first go to the base class constructor where the value of private A is 1, 2 and public A is 3. So again use step into, it you will see that now it will jump to the parameterized constructor and not, oh sorry, I clicked on step over, I should actually use step into. Now it has jumped to parameterized constructor of parent class, value of A, private A is 1, protected A is 2, public A is 3. It will then execute these three members. Three members of the base class are initialized. Now it will jump to the child class. Now in child class, do we need to redo this again? We have already done in the base class. Protected A is assigned a value 2 already. So let us comment it. Oh, we are in run mode. We would not be able to edit the code. Let's stop it. We'll come back again. So these two lines we don't have to do in child class constructor, as these two lines are already executed in the base class constructor. In simple words, from child class, when you are calling a base class constructor, the base class constructor is taking care of initialization of the base class field members. We don't have to again initialize them in the child class. See, something very beautiful here is the problem of private member not accessible in child class automatically solved here. Private member of parent is not accessible in child. So in child I cannot initialize. But what are we doing here? From child class constructor parameters, we are passing data to base class constructor. Base class constructor is initializing the field members, and then rest of the data is passed to, then the execution jumps to child class where it has to only initialize child class members. It doesn't have to now initialize base class member. Let us again step into. From here it goes to base class. Three members of the base class are initialized. Now it jumps to child class. Now the only member of child class, that is PUBB, has to be initialized. Like this, now you'll know that all the four members PUBB of the child class, PRIA, PROA, PUBA, all the members of the base class are initialized with the help of this data. So point is very clear now. Whenever a child class object is created, it would first jump to the appropriate constructor of the child class, and by default it jumps to the default constructor of the base class. Unless and otherwise you might have put base, in which case it will jump to the appropriate constructor of the base class, execute that first and then come to the child class. A simple architectural design in inheritance you have to follow is always try to initialize members of that class in the constructor of that class only. In the sense, don't try to set the value unless and until you want to overwrite, which is a different case altogether. Don't try to set the value for the member of the base class in child class. Instead, what is recommended is child class can get the data and we can pass that data to the base class constructor, so that base class constructor does the initialization of its member and child class member constructor can do the initialization of its own members. Very clear on this point? I repeat. Whenever a child class object is created, pass all the data required for every field member to the child class constructor. Write child class in such a way that child class can pass data to the base class constructor. Base class constructor will initialize its own field members. Then the child class constructor will execute and it would have to initialize its own field members, where it doesn't have to take care of now base class field members, unless child class want to do something else for the base class field members. And of course, child class can access only public and protected members of base class. It cannot access private members of base class. It cannot do anything to the private member of the base class. So does it also answer to our question why the order of execution is parent to child, which we have already answered before, and why the order of visiting is child to parent class constructor? So that child class constructor can pass appropriate data to the base class constructor. Hope it's very clear. Next is, now let us do something special. I have parameterized constructor here. I have default constructor here. And we already know that the default constructor of child class is going to first execute this default constructor of the parent class. What if the base class, the parent class, does not have a default constructor? Let me comment this out. You can use Control K C as a shortcut. Select all the text and press Control K C for comment and Control K U for uncomment. Now try to build the program. It's a compilation error, pretty obvious. A parent class does not contain constructor that takes 0 argument, and child class is dependent on that constructor. What should I do in these kind of situation? One option is very simple, that is delete this also, because default is not there in parent. Don't keep default in the child class also. But by chance, if the requirement says I want child class constructor, the default constructor in the child class, in such case put here colon base of, simply put default values for all the 3, 0, 0, 0. This way, when the object of child class is created using default constructor, instead of now jumping to the default constructor or searching for it, it is now going to jump to the parameterized constructor of the base class. Simple words, every child class constructor must compulsorily link to an existing constructor in the base class. If there is no keyword base here, by default it will try to link itself to the default constructor of the base class. Very important. It's all correct now, no errors. Clear? So this is all about constructor topic, and just for the reference, order of execution of destructor is always child class destructor first, and then it executes parent class destructor, reverse to that of constructor. Let us now switch over to the notes and see all these points. I would want you to read all these points at a stretch. Please do that. Spend some time on this slide. Please do not hesitate to post a question in case you don't have understanding about any of these 10 points. But I am pretty clear. You may want to look at the video once again on all these points which are already covered. Let us go further now to the next topic. Typecasting in reference type. Typecasting of reference type. Let us minimize all. I mean, we can actually delete this. We don't need this anymore. Just to avoid confusion, I'm keeping few members only in parent class and few members in child class.